This video will cover creating data summaries in ggplot. By the end of this video, you'll understand why you might summarize data in visualizations as part of your workflow, and you'll understand what some ggplot visualizations are for summarizing data. The example code used in this video is available on the Learning Management System. We're going to use the iris dataset, which is built into R. In this video, we're going to create data summaries. These are representations of summary statistics of your data. But what are summary statistics? These are numbers or visualization elements that summarize your data. These could be measures of the center of your data, something like the mean, the median, or the mode. Measures of the distribution, things like the minimum, the maximum, or percentiles of your data. Variance, common measures are standard deviation, or the interquartile range. Lastly, you might want to be able to identify outliers in your data. This would be a list of observations with extreme values in your data. But why do we care about summary statistics? They help us understand our data at a glance. They'll tell us what the typical values in the dataset are and how much variation there is. ggplot has several geometries that are designed specifically for summarizing data. The first geometry that I'd like to talk about is stat summary. It can be really useful for displaying summary statistics. This geometry takes two aesthetics. The X aesthetic tells R how you would like the data grouped. Different groups of data are going to appear on the x-axis of your visualization. And Y tells R which value in your data set to summarize. This visualization is going to show a line that covers a range. The bottom of that range will be defined by fun.min. The top of that range will be defined by fun.max. And also a dot showing something in the center. There's many possibilities for what this range and dot can be. You could specify them using min, mean, max, or median. But really, any function that summarizes data can be used. Let's create a visualization using stat summary in R. I'll load my setup code first. Now let's take a look at my example code. So in this first example, I have a basic use of stat summary. Again, the geometry requires a data argument. We're going to use the iris dataset. I provide it with two aesthetics. The first is how I would like my data grouped. I'm going to use the species variable. The Y aesthetic is the variable that I would like to summarize. Here I'm going to use sepal.width. The other piece of information that I have to provide to stat summary is how to draw the line and the dot. So here I'm saying that I'd like the dot to be the mean of my data, the bottom value of the line to be the minimum in the data, and the top value to be the maximum of the data. Let's run this code and see what we get. Taking a look in the viewer window, there's a new visualization. You can see the x-axis is broken out by the three values of the species variable. Each column has a line and a dot. Again, the range of the line represents the minimum and the maximum of sepal width for that particular species, and the dot represents the average value. The mean, the min, and the max aren't the only options for how this can be drawn. Let's take a look at some other code that I have. In this next example, I changed the location of the dot to the median. Let's run this bit of code. And you can see I get a new visualization where again the line represents the range from the minimum to the maximum value for that species. The dot now represents the median. This visualization is less than ideal. It could use labels to better communicate the information to the viewer. Let's take a look at another piece of code. Here what I've done is added some aesthetics to change the color and the size of the lines and dots that are drawn. And then I add labels to communicate what information is actually being shown in the visualization. Let's run this code. Taking a look in the viewer window, you can see the lines are a bit heavier. They're colored blue. And now there's additional information in the labels to communicate to the viewer exactly what is going on in this visualization. In stat summary and other visualizations that we'll look at when there's a categorical axis, R is usually going to organize that axis in either alphabetical or numerical order, depending on the data type. This may not always be the way that you want your axis organized. You can change the order of the axis using the factor function inside of the aesthetic. The way this works is you use factor, you specify the variable you would like the data grouped by, then you provide an additional argument, levels equal to, and then you give a vector of the data in the exact order that you would like it to appear on the axis. So if you remember the visualization that we made before, organized the x-axis in alphabetical order. The species were Setosa, versicolor, and virginica. Let's say we'd like to put those in a different order. Looking in the code window, I've modified the X aesthetic of this previous visualization to add the factor function. Again, I specify the variable that I'd like to use to group the data as the first argument to factor. Then I provide the labels argument, and then I give a vector containing each value in the order I would like it to appear on the x-axis. Let's run this code. And you can see, looking at the visualization now, the order of the x-axis has changed to the order that I specified in that vector. So a second type of summary visualization is a histogram. Histograms are a very specific type of bar chart. They group data and show the count or the frequency of data in each group. These are excellent for exploratory analysis of your data because they're going to show the distribution or variation that you have in your data. You can create a layer with a histogram in ggplot using geom histogram. It only requires an x aesthetic. This can be a continuous or a discrete variable. If it's discrete, you're going to get something similar to a bar chart. If it's continuous, R is going to take your x variable, break it up into bins, and then the height of each bar will correspond to the number of observations in that bin. You can control the width of the bins using the layer property bin widths. Alternatively, you can control the number of bins using the layer property bins. So let's create a histogram using the iris data. In this first example, again, I set the layer geom histogram, the data equal to iris. I only need to provide the x aesthetic, which again, I'm going to use sepal width here, and I'll set the number of bins equal to 20. Let's run that code. Now you can see in the viewer window that I have a histogram. Again, the height of each bar corresponds to the number of observations, where the sepal width falls within the width of that bar. Again, this is a nice way to analyze the variation that's in your data. It also shows which values are common and which values are uncommon in your data. This visualization is maybe a little difficult to read, so going back to my code. In this example here, I set the fill color equal to blue. This is going to set the interior color of every bar. I set the color equal to black. This is going to draw a black line around every bar. And then lastly, I add some labels to the visualization, again, to communicate what's going on in the visualization to the viewer. I'll run all this code. Taking a look in the viewer window, you can see a similar histogram. Now all of the bars are blue with a black outline, and there's labels in the visualization telling us exactly what information is represented there. The final type of visualization that I'd like to cover here is the box plot. You can add a box plot layer to your visualization with geom box plot. This is going to create a traditional box and whisker plot. A box and whisker plot usually shows a line representing the full range of what R determines as non-outlier data. A box containing the 25th to the 75th percentile of your data. This is the interquartile range. A horizontal bar showing the median value. And then dots representing values that R determines to be outliers. Box plots are very useful for data exploration because they provide a lot of information about the distribution of your data at just a glance. Similar to stat summary, box plots take two aesthetics. You're going to provide an X variable telling R how you would like the data grouped, and a Y aesthetic specifying the variable you'd like to summarize. So here I have some sample box plot code. Again, using the iris dataset. On the x-axis, I'd like to group the data by species, and then I would like box plot summaries of the variable sepal width. Since I'd like to create an interpretable visualization, I'm going to add labels to my visualization right off the bat. Let's run this bit of code. Now looking in the viewer window, you can see the box plot visualization. For each species, the vertical bar represents the range of what R has determined to be non-outlier data. The box represents the 25th to the 75th percentile, or the interquartile range, and the horizontal bar represents the median value. You'll notice there's dots in some of the columns. These are values that R has determined to be outliers. I want to caution you that this is just an algorithm that R has to flag observations that are outliers. They may not actually be outliers in the sense that they're anomalous data. This is just a method that you can use to identify extreme values. To determine their outliers, you might want to investigate further. So again, these are some methods of visually summarizing your data using ggplot.